The Magical Mathematics of Music by Rusty Waller. Music, often described as the universal language, is essentially organized sound. The interplay between mathematics and music is evident in various forms of creative expression. The circle of fifths, for instance, underscores the shared skills required to master both disciplines. When the legendary jazz saxophonist, composer, and bandleader John Coltrane sought to illustrate his understanding of music, he turned to mathematics. Coltrane expanded the circle of fifths, a geometric diagram mapping the spatial relationships between musical notes with his own concepts of tonal relationships. His drawing, known as Coltrane's Circle of Tones, has inspired numerous essays on musical geometry. The relationship between mathematics and music is deep and symbiotic, stretching back centuries. This connection is not coincidental. Math is integral to the structure of music, from organizing musical scales to the physics that shape an instrument's sound. Mastery in one field can enhance abilities in the other. Prominent Princeton University mathematician Manjul Bhargava, who is also a renowned tabla drum player and poet, encapsulated this synergy in a Quantum magazine story. All kinds of creative thoughts come together when I think about all three. This integration challenges the stereotype of mathematicians as solely left-brained scholars uninterested in or incapable of soulful expression. Mathematicians often find beauty in mathematical proofs akin to the beauty in music or art. To explore this connection further, we must travel back to ancient Greece. Pythagoras, a key figure in both mathematics and music, made significant discoveries while experimenting with a taut string. Imagine a stretched rope attached at both ends. When plucked, the string vibrates. Pythagoras divided the string in half and plucked it again, producing the same note but an octave higher. He then divided the string into three parts, producing a different note that harmonized with the first. These divisions, represented by the ratios 1/5 and 2/3, created pleasant harmonies due to their mathematical relationships. Our brains appreciate well-defined logical relationships, and Pythagoras continued creating scales through mathematical subdivisions, leading to the development of musical instruments that could reproduce these scales. Over time, the notes were given the names we use today. Generally, the human brain perceives sounds as pleasant when they have small values in the numerator and denominator of a fraction, linking each note to a rhythmic pattern that the brain finds pleasing or displeasing. Another essential aspect of music is timbre, which distinguishes a piano from an electric guitar, for example. Timbre can be mathematically analyzed using Fourier transformations. This analysis reveals dominant frequency components in an instrument's sound. For instance, an electric guitar and a piano may play similar chords, but their timbres differ due to the unique frequency components of each note. Software can expedite this analysis, showing that while a piano might have a smoother sound, a guitar might produce a more jagged or rough timbre. However, timbre is complex and subjective, and mathematical analysis alone may not fully capture it. Musical scales are also fundamentally mathematical. Scales are divided into modes, which can be mathematically defined by the arrangement of tones according to their pitches. For example, the C major scale consists of 7 distinct notes: C, D, E, F, G, A, B. Modes are variations of scales based on the intervals between notes, whether ascending or descending. With 7 distinct pitches, there are 7 possible modes, illustrating how different types of scales emerge from varying step patterns between notes. Mathematics helps us understand musical frequency, pitch, wavelength, and velocity. The frequency of a sound determines its pitch, while the wavelength measures the distance between peaks in a wave. These principles explain how music sounds high or low. Composition and form in music are also mathematically connected. Composition refers to how musical pieces are structured, while form can describe both individual piece structures and how pieces interconnect. Symmetry, another mathematical concept, appears in music through patterns like bilateral and rotational symmetry. In conclusion, music and mathematics share profound connections, only briefly explored here. This relationship invites further investigation into the intricate ties between these two disciplines.